Hello there, this is Brenda here, and in this video it's all about OSPF, Open Shortest Path First. So Open Shortest Path First is a routing protocol for Internet Protocol, that is the IP. So IP networks rather. So it uses a link state algorithm, and it falls to the group of interior gateway protocols. So the interior gateway protocols are the protocols that operate inside like it's not out in the internet, but in an organization like an enterprise. So yeah, it operates, and also it operates within a single autonomous system. So for instance, this one over here, it is in a single autonomous system. So a single autonomous system is for example, let me cancel that. This one over here, all of this is in area 0. Area 0. Perfect. So that is what we are talking about in autonomous system. So it's in area 0. So in simple words, it follows the path which is the shortest. So if, for instance, this router wants to communicate with this one, it has two ways to go there, to get there rather. So it can pass over here from this other router and then to here in this direction, or it can come this direction. So in that case, it can consider, the distance. Also, if this one here is using say 100 bps, this one is maybe 10, it's going to choose the one that is faster. If it is 100, 1,000, this one is going to be 100 and 100, and then this one will be 10. So it's going to, this 10 is going to be slower compared to the 200 over here. So it is actually choosing the best path. So that is OSPF. And there are many states in OSPF. It has to start with the hello, and then it has to know it has to have the data descriptions, and then the request, and then the updates, and then the acknowledgements. All that goes through this area. Also, you have to know that OSPF also uses the area factor and also uses wildcard mask. Yeah, so we'll get into that in just right now. Okay, so first and foremost, what I'm going to do is to give these routers IP addresses. Yeah, so this one has 1, 2, 3 interfaces. So in the 3 interfaces, I'm going to give them all the IP addresses, which means that I'm going to give the one for this network and that network and this other network. So to do that, we are going to configure first the name of this router. So host name is going to be R1. Simple. Then in this R1 now, we are going to first configure the gigabit. So it's first gigabit. Now the IP address. Remember, this one is 192 network, 192.168.1. I'm going to give it a .1 for this router, and then now the subnet mask 0. Then now shut. You go to another interface serial 0/1 and 0. IP address is going to be 10.0.0. I give it 1 and then 255.0.0.0. This is just for simplicity purpose. It's not like on an environment that is enterprise or anything. So I'm only doing this simplification because it's an example. Yeah, so it's not a real environment. So there's no subnetting or whatever. So no shutdown. Perfect. So we come to the next interface, which is in the same router, S0/1 and 1, and then IP address is going to be 12.0.0.1. Subnet mask is 255.0.0.0. No shut. Now all the interfaces in this specifically in this router, this is router 1, they are all up. So which means that they when they are up, they can communicate with the rest, but these ones cannot receive any communication or any update or whatever when they are not on, or up rather, when they are not up. So these are the router here. It's going to be router 2. So I'm going to configure it as a router 2. So host name is going to be R2. So the interfaces that are there are only 2, so it's the 2 serial interfaces. So serial 1 and 0. So IP address 10.0.0.2. I'm giving you the 2 because the other one has taken .1. So yes, that is why. Okay, so wow, oh, the subnet mask 0.0.0. Yes, no shut. Perfect. So the next interface in the same router is interface S0/1. Okay, IP address. This is another network, so it's 0.0.1. I'm going to give the 1, and then 255.0.0.0. No shutdown. Perfect. So we get to the next router. This is going to be router 3. Alright. Okay. So there we are. Host name, I'm going to give it hot 3. So that the interfaces in this router are 2 also. So it's interface 0/1/0, and then the IP address, well, here is going to be 11.0.0.2 255 0.0.0 .0, yeah. Then our no shots. The next interface is interface 0.0.1.1. IP address. This one is actually these are going to be 3 interfaces, so it's 12.0.0.2 because the other one has taken .1. 55. Ooh, this is just 8. So there we are. No shut. Perfect. So we get to the next interface, that's the gigabit interface, G000. Oh, 0.0.0.0. No, wait. I may say no. Interface G000. And then the IP address is 192.168. This is .2 network. Yay, .2.1. Yep. So 255.255. What? 2. Okay. 55. And then too many dots here. 2 missing. The 0. No shut. Perfect. Now all the interfaces are up. Now what I like about this is that when all the interfaces are up, it is easier now to configure whatever thing that you want. So if it is OSPF, EIGRP, RIP, whichever protocol you want to come into place here, and then you can also use static routes, whichever routing protocol you want. So yeah, for me this is all about OSPF. So I like when OSPF are in the interface. So like I mean, it's my favorite way of configuring OSPF rather. So what I do is to go back to the interface. I'll start with the G00. Yeah, and then now I come up with the IP OSPF, and then now this is on the autonomous number is going to be 1. Yes, and then now the area is going to be area 0, just like the way I've put it over here. So yeah, area 0. Now when that is done, I go to the next interface, S0/10 IP OSPF 1, and then the same area 0. And then we come again to the other interface, the S0/1/1 IP OSPF OSPF 1 area is 0. Perfect. So all the interfaces in this router, they are all in OSPF. Yeah, so they can all do OSPF, this one, and that one. So as you can see here is G00, S0, that one, and then this one. Now after that is when I configure the router as the OSPF exit. So to do that, I'll use the command O router and then OSPF, and then now the autonomous 1, and then now the networks here, the networks that are supposed to be connected to. You see, this router here, as the neighbor of this one, they're directly connected to this one, and this network. So the networks that cannot be reached by this router are 2. So it is the 11 network and also those 2 network. This cannot be reached. So to do that, to reach the other networks, which is the ID, I mean the whole point of routing, and is to reach other networks that are not reachable. So to do that, you're going to have the network, and then now the 11 network, the 0, and then you remember that this is OSPF, and OSPF uses the wildcard mask. It does not use the subnet mask. So in OSPF, it's not the same as this one over here. This is just configuring our router. Now in OSPF, we use the concept of wildcard mask. So wildcard mask is when you do this, is when you minus 255.255.255. That's the broadcast, and then you minus it to the subnet mask of that specific router, the interface of that network, subnet mask of that network. Yes, so if that network was 255, like in this case, so it's 0, then 0. So you will minus this one and then this one. So to get the answer is going to be 0, because 255 and 255 become 0. And then the rest are going to be 255 and then 255. 255. So this is what is called the subnet, the wildcard mask here. Yeah. So that's what I'm going to use here for this network. So because it was a .8, so /8 rather. So it's going to be like 0.255.255.255. Then now, not forgetting that it is in area 0. Perfect. The next network that this router cannot reach, which we want it to reach, is the 192, this network here. This one here. Yes. So it's 192.168.2.0. So that one is going to be 0.0.0.255. Same area, 0. Perfect. So after that, we are going to the next. Let me save this work first. Do copy 1. Start. Perfect. So come to the next router. That's router 2. We get started here with the interfaces and introduce them to OSPF. So there are two interfaces here. So it's interface 0/1 0. So it's IP or SPF, and then now it's autonomous 1 area 0. Perfect. The next interface is S011 IP or SPF. Oh, they just they made that adjustment, so it's OSPF forward. OSPF. No, let me just, I can't see when that one is distracting me. So it is IP or SPF, and then now the autonomous number, and then area 0. So yeah, they are done. Now there are two interfaces, so it's this interface here and this interface there. Perfect. So what we do is now configure the route and the route. Okay, router OSPF. Now we still have the autonomous as one. And then now the networks that this router cannot reach. It can reach this one and this one because they are directly connected, but cannot reach this the 12 network. The 12 network and .1 and .1 network. These other three networks. So that's what we're going to do. So to reach those three networks, we're going to have the command. Sorry, excuse me. The 12, the 0 network, and then the mask, the wildcard mask 255. Excuse me. 255.255. Yes, and then our area is 0. Perfect. The next network that it cannot reach is 192. Network is 192.168.1.0 0.0.0.255. Area 0. The next network it cannot reach is we want now to reach is 192.168.2 0.0.0.255. Perfect. Yeah. Human hair. Okay. So after that, we can come to the next router now, because all is good. Let me just save this one. Do what? No, it's not do right. Let me do copy. Perfect. Alright. So what now? The next thing we are going to do is to come to the next router. This one is so it's connected to 3 interfaces. So 1, 2, 3. Yes. So we introduce these interfaces to OSPF. So it's interface S0/1/0 IP OSPF 1 area 0. Yes, so this one is going to be like that. What did I use instead of 0? Okay, yeah. Right. So interface, the next interface is serial 0/1/1. There we go. So there's an adjustment that is happening here. IP OSPF 1 area 0. Perfect. So another adjustment that is happening, interface which interface is that? We are done with this. Done with that. So it's the gigabit interface remaining 000. Perfect. So it's IP OSPF 1 area 0. Perfect. So now we are done with the interfaces. Now we come up with the router and connect to other interfaces and other networks that are so far away. So the networks that are not directly connected to this one, to R3, is the 10 network and 192.168.1 network. So that's what you're configuring. So it's the 10 network, 0.0.0. Wildcard is 255.0.555 area 0 area 0. Perfect. Where did I go wrong? I think there's a problem here. Yeah. Oops. Oh, wait. I haven't even used the word router or OSPF, and here I am running and rushing. I don't know where. Okay, router OSPF 1. Then now we are in the router config mode. So it's the .10 network, and then 0.55.255.255, and then area 0. Oops. No. Okay. This router is refusing my commands. The next network is the 192.168.1.0, then 0.0.0.255. Area is 0. Perfect. So, and then now I'm going to do the copy, run, start. Perfect. All good. So to see if everything is doing okay, let's check this out. Let's do show IP route and see what's happening. Oh yes, so here the directly connected interfaces in this router, the OSPF here is also available. So in this network, the 10 network is now convergent with these other ones. So this the 10 is there. Okay, link .1. I'm looking for the .1 network. Oh, here it is. So even the OSPF has allowed this one to be there. So there's this network and this network which was configured through OSPF. The rest were directly connected, and also they are locally, the ones that are the local networks. So yeah, that is good. Let's check this out too. Do show out. Perfect. So even this one, the two networks that were very far away, they are now reachable by OSPF. The 192.168.1.0 and also 192.168.2.0. All of these are reachable now. So when all these are fine and good, let me see if this router can ping with this other one. But before that, I'm going to configure this PC rather with the IP address, because it has no IP address. So 192.168. It is in the .1 network, so I'm going to give it .1.3, and so that's the default. Now the default is going to be 192.168.1.1. Perfect. So there we are. And these are the PC. I'm gonna give it an IP address as well. So this one is in 192.168.2. I'm gonna give it also .3, and then 192.168.2.1. that's the welcome. No, that's the default gateway. Perfect. Now let's try and ping the neighbor. First I'll try and ping if it can, if it can reach its default gateway. So I'll try and ping 192.168. Is it 101? Yes. Perfect. So as you can see here, it's pinging and it is reachable to its default gateway. Now let's ping to that other PC. So it was 192.168.2.3. Alright, this is going to take a while because this router has to go through many routes. Perfect. It is reachable. As you can see here, it is reachable to this other network. Whoa, okay. So I think I'm going to trace route and check which router, if this router took this other network or took this short network. Oh, come on. Because this one has to go to this one and then goes to this one. Yeah, let's check this out. So trace route. Trace RT. Oh, yes. No. Trace route. Okay, 192.168.2.3. Oh, okay. Let's check this out. No, let me just ignore. Let me check this one first. Yep, 192.168.1.3. Yes, it is reachable. Amazing. Let me try and trace out this one also. This one, now. Oh wow. Let me just, this one I'm going to come up the next time with the other command. Let me check first something here. Enable show IP OSPF. Yeah. Interface G000. So yeah, it's all good. It's a broadcast. Cost is one. Yeah. Alright, that's the end of this OSPF so video. Yes, and thank you for watching, and yeah, please like.